How could Tu Youyou deceive the Nobel Prize and the Lasker Foundation Award in Medicine? Lecture 2. Tu Youyou's sample 191 was so toxic because she chose the wrong extracting source Qinghao and the wrong solvent ether. 2015 Nobel Prize in Medicine winner Tu Youyou was an academic cheater and a liar. She was not the crucial contributor of 523 project in finding the new anti-malaria drug artemisia. The government of Ministry of Health of China selected her as a candidate in attempt to bring the best political propaganda effect for the ministry. As a matter of fact, Tu Youyou has made the biggest academic cheating scandal in world scientific history. Tu Youyou deliberately covered the toxicity of sample 191 in her Nobel Prize lecturing speech. Please listen.
1971年4月10月4号，青号一米中性提取物就是标示的191号样品，以1公斤体重1克体的剂量，连续3天口服给药，取悦药效评价显示抑制率达到100%。同年12月到次年1月猴月实验也得到了抑制率100%的结果。青蒿乙醚中性提取物抗疟药效的突破是发现青蒿素的关键。
There are two different inhibition rates. One is inhibition rate for live mouse. Another is overall inhibition rate for all mouse, dead or alive. The relation is overall inhibition rate equals inhibition rate for live mouse times the survival rate. In the process of searching for anti-malaria drugs, all 523 project teams have a common mouse malaria test criterion as follows. The survival rate of mouse and the inhibition rate of live mouse must be both above 90%. Therefore, the minimum requirement for the overall inhibition rate must be larger than 90% times 90% equals 81%. Let's go back to see Tu Youyou's sample 191 experimental record paper. From the last lecture, we know that number 4/5 is the death rate. So in this column, all the numbers are death rates. Also, the number 100% is the inhibition rate for the live mouse. Now we add the survived rates, which are 1 minus the death rates. At last, we calculate the overall inhibition rates for each drug on this paper. Then we can see none of the overall inhibition rates is larger than the critical value, 81%. Particularly for the sample 191, its overall inhibition rate is only 20%. Therefore, the sample 191 was definitely not a research breakthrough point for discovery artemisia. Therefore, we urge the Lasker Foundation and the Nobel Prize Committee to thoroughly investigate the overall inhibition rates of Tu Youyou's sample 191. This is because that Tu Youyou's cheating scandal has also damaged your academic reputations. Moreover, the NIH official should investigate whether Dr. Su Qingzhuang committed perjury, helping Tu Youyou to steal the Lasker Award and the Nobel Prize. If that was true, then Su Qingzhuang should be punished. Now let's check sample 192 in this experiment record. The drug used for sample 192 is the same used for sample 191, but reduced the dosage from 0.8 gram to 0.6 gram. The inhibition rate for live mouse is down from 100% to 85%. However, the survival rate was increased from 1/5 to 3/5. Therefore, the overall inhibition rate is increased from 20% to 51%. This was an evidence to show that Tu Youyou already knew the sample 191 was too toxic. Therefore, she tried to reduce the dosage such that could increase the survival rate. Let's check sample 193. The drug used in sample 193 was marked as the double extraction. It was extracted from the residue of the sample 191 with 95% ethanol. This time, although the inhibition rate for live mouse down to 77%, however, the survival rate increased to 4/5. Therefore, the overall inhibition rate increased to 61.6%, which was better than sample 191 and 192. That tells us that Tu Youyou used the 95% ethanol to wash out the residue from sample 191 to get the lower toxic drugs. Now we check sample 194. The drug used in sample 194 is the same used in sample 193. Just reduce the dosage. In this time, although the death rate is 0, however, the inhibition rate down to 26%. Those 3 experiments clearly indicated that Tu Youyou knew that the 100% inhibition rate of live mouse for sample 191 was nothing, when the death rate was too high. Therefore, she continued to try several ways to reduce the toxicity and increase the survival rate. However, Tu Youyou never told the judges of Lasker Foundation and the Nobel Prize about this true reality. She pretended that sample 191 was perfect and not toxic. Therefore, this was absolutely a cheating. In the margin of Tu Youyou's report on March 8, 1972, the 523 project office leader Zhou Keding made a handwriting notes as the following picture shows. Zhou Keding only wrote one word, 毒性大. The English meaning is too toxic. This was the evidence that the 523 project office did not positively confirm Tu Youyou's report on March 8, 1972 because of high toxicity. Now we have a question. Why Tu Youyou's sample 191 was too toxic? To solve this puzzle, we need to look at Tu Youyou's 2 experiments. The first one was in her report on March 8, 1972. The following was a copy of Tu Youyou's experimental record. This record tells us if ethanol was used as solvent, then the extraction would be no toxic because the death rate was 0, although the inhibition rate was only 40%. The second experiment was about the sample 193. Let's go back to look at whose death rate only 1/5 and the inhibition rate for live mouse was 77%. Tu Youyou explained the sample 193 was used the double extractions. First, extract with ether, then use 95% ethanol to furtherly extract the residue from the first extraction. Combine the above two experiments, we got the following conclusion. The toxicity of sample 191 was from the ether extraction. Because ether is a too strong polar solvent which could extract anti-malaria ingredient from Chinese medicinal Qinghao, but may extract some toxic substances too. Therefore, the ether extraction was not a correct choice, certainly was not deserved to get the Lasker Award and Nobel Prize. What is the correct choice of solvent for extraction? To solve this puzzle, we only need to go to the artemisia pharmaceutical factory to see which solvent they use now. They all use the number 120 gasoline as solvent for extraction. No one uses ether. The gasoline solvent method was invented by Institute of Material of Medical in 1974. Another factor caused the toxicity of sample 191 was the sauce used by Tu Youyou for extraction. The raw sauce used by Tu Youyou for the anti-malaria ingredient extraction was called Chinese medicinal Qinghao. Please listen how Tu Youyou said in the Nobel Prize lecture.
中医药研究所团队于1969年开始抗疟中药研究，经过大量的反复筛选工作后，1971年起，工作重点集中在中药Qinghao。
In the video above, Tu Youyou clearly said that from 1971, her team's anti-malaria research work was focused on Chinese medicinal Qinghao. In Chinese, 中药Qinghao. Now we have a question. What was Chinese medicinal Qinghao in 1971? To answer this question, we have to read the Chinese Pharmacopoeia of 1963 edition. This is 1963 edition Chinese Pharmacopoeia. We can see that Chinese medicinal Qinghao was printed in page 154. The detailed definition of Chinese medicinal Qinghao is the following. In the first line, the Chinese word is named Qinghao in Chinese writing. In the second line, the English word Qinghao was the Latin name for medicinal Qinghao, but it also was the Chinese spelling of Qinghao. Its medical application was clearly written, can cure malaria, cold, and fever. This was an evidence that Chinese medical scientists already knew the existence of anti-malaria ingredients in the traditional Chinese medicine of Qinghao as early as 1963. Tu Youyou's experiment on sample number 191 was only a try to verify this reality, and certainly not a new discovery. However, because of toxicity of sample 191, she failed. The following is a complete translation about the original source of Chinese medicine of Qinghao. It was defined as the dried leaves and stems from two different kinds of artemisia plants. One was Artemisia apiacea hens, whose Chinese name is Qinghao. Another was Artemisia annua L, whose Chinese name is Huanghua. Both artemisias are very similar in appearance, but their growth conditions are slightly different. Botanically, Artemisia annua L needs more sunshine and raining. Therefore, it is primarily located in the southern part of China. This pharmacopoeia is the Chinese drug law. According to this law, Chinese farmers have to harvest the medicinal Qinghao before the summer flowers. Therefore, in the next year, the plants will no longer grow in the same field because no seeds left. Such a peculiar harvest method would make the anti-malaria ingredient of the medicinal Qinghao unstable. That was why Tu Youyou's inhibition rate of ethanol extraction varies from 40% to 80%. Tu Youyou's employer, Academy of Traditional Chinese Medicine, had a warehouse in charge of purchasing all medicines and equipments for the institutes. Tu Youyou had to submit pickup forms to get the medicines from the Academy warehouse for her 523 project team's anti-malaria experiments. In the 1970s, those pickup forms were the handwriting notes. The following picture was a photo of one Tu Youyou's such pickup forms. This pickup form was filled by two persons. The left half side was written by Tu Youyou's teammate Yu Yagang. The right half side was filled by Tu Youyou herself. In the first line of the left side, it was written 523 research teams needs to pick up the medicinals as following. We can clearly see that medicinal Qinghao was listed in the left side. Moreover, in the right side, Tu Youyou listed the medicinal Qinghao too. In 1977, Chinese Ministry of Health made a revision for Chinese pharmacopoeia. Basically, the medicinal Qinghao was the same as before. Here is the partial English translation. The medicinal Qinghao is still the mixture of two artemisias. However, the editor wrote Artemisia annua first and Artemisia apiacea second. In 1985, Chinese Ministry of Health made a big change to medicinal Qinghao in the new edition of pharmacopoeia. The medicine source was defined as a single plant, Artemisia annua, and not the mixture anymore. This change was based on Tu Youyou's suggestion. In a paper published in 1987, Tu Youyou explained why to make this change. She said that the main reason was because only Artemisia annua has anti-malaria ingredient. Now we make the following table about original source plants of medicinal Qinghao from year to year, according to the Chinese pharmacopoeia. First of all, from 1963 to 1984, the original source plant of medicinal Qinghao was a mixture from two different artemisia plants. However, the ratio was random. It could be 100% Artemisia annua or 100% Artemisia apiacea or 50-50, which depends where the retailer purchased those medicinal Qinghao. After 1985, the medicinal Qinghao was from Artemisia annua only. However, the quality could be very different. In some regions, Artemisia annua could have no anti-malaria ingredient at all. From October 1971 to August 1973, Tu Youyou extracted the anti-malaria ingredients from purchased commercial medicinal Qinghao with solvent ether. Tu Youyou has never gone to the wilderness to pick Artemisia's plant so far. For a long time, Tu Youyou was criticized for using the wrong source Qinghao for extraction. More seriously, some scientists even claimed that Artemisia apiacea would generate toxic substances by ether extraction. That was why Tu Youyou wanted to change the definition of Qinghao desperately. One crucial cheating strategy of Su Xingzhuan and Tu Youyou was using the current source standard of medicinal Qinghao to replace the standard in 1970s. This was because that the ether extraction on Artemisia apiacea will generate toxicity. Since Dr. Miller and all judges of Lasker Award and Nobel Prize were unable to read Chinese pharmacopoeias, they were fooled completely by Su and Tu. In the Lasker Award paper, Artemisinin Discovery from the Chinese Herbal Garden, joined with Dr. Miller, Su Xingzhuan said, among the promising results, extracts from Artemisia annua. In here, we can see that Su Xingzhuan used parentheses to refer this Artemisia annua was Chinese medicinal Qinghao. However, this is not the definition of Qinghao in 1971. Clearly, Su Xingzhuan had removed Artemisia apiacea from the source of Qinghao used by Tu Youyou in 1971 because he wanted to cover the toxicity of sample 191. In the paper, The Discovery of Artemisinin and the Nobel Prize in Medicine, joined with Dr. Miller, Su said a plant called Qinghao or Artemisia annua was one of the plants that appeared in the recipes frequently. Let's stop here. Once again, Su set an equal sign between Chinese medicinal Qinghao and Artemisia annua to cover the toxicity of sample 191 and cheat the judges of Nobel Prize. In the Lasker Foundation paper, Artemisinin therapy for malaria, the editor said one of the extracts looked particularly promising. material from Qinghao, artemisia annua, dramatically inhibited parasite growth in animals. It was obviously that judges of Lasker Award believed the medicinal Qinghao used by Tu Youyou in 1971 was the same as artemisia annua. Moreover, they didn't know the toxicity of sample 191 at all. Therefore, they were fooled by Su Xingzhuan and Tu Youyou completely. In the paper, Artemisinin Revolutionary Therapies Against Parasitic Diseases, the Nobel Prize Committee wrote, the plant Artemisia annua turned to be an interesting candidate, and Tu developed a purification procedure which rendered the active agent, artemisinin, a drug that is remarkably effective against malaria. It was obviously that the judges of the Nobel Prize believed that Tu Youyou used artemisia annua for extraction and didn't know the strong toxicity of the Tu Youyou's purified substance. Therefore, they were also completely fooled by Su Xingzhuan and Tu Youyou. In the last lecture, we appealed the Lasker Foundation and the Nobel Prize Committee to conduct the investigation on whether Tu's sample 191 was toxic. In this lecture, we continue to appeal the investigation should include whether the medicinal Qinghao used by Tu Youyou in 1971 was a mixture, and the toxic substance of sample 191 was from Artemisia apiacea by Tu Youyou's ether extraction. More Tu Youyou's cheating material will come later. Bye-bye.